Our first lesson today is going to be about looking at the idea of exploring accumulation of change. So the first thing we're going to do is we're going to look at basically what's called a rate in, rate out problem. So we have some snow on Janet's driveway. It's going to be a snowy one, although we did not have any snow this year. At midnight, there are 80 cubic feet of snow on Janet's driveway, so you can think of that as a volume. Snow accumulates at a rate of 50 cubic feet per hour. We also know that at 6 a.m., Janet's going to get up. She's going to start shoveling. And we want to know whether or not she's going to make it out of her driveway in time, I guess, to go somewhere. So the first thing is this idea of how much snow is on her driveway at 6 a.m. So keeping in mind, we're kind of setting up some calculus concepts that are coming, but the idea is that we're going to have the amount at midnight, our starting amount, and then we're going to add to that the accumulation that happens for those first 6 hours. So you'll hear me use the words accumulation and the words net change quite often interchangeably in this set of notes. And this would be the net change from time 0 to 6 in our problem. So we have a starting amount plus our net change. So it's fairly straightforward in terms of calculating. We started with 80 cubic feet of snow on the driveway. And then to calculate our net change, since this rate that we have is a constant rate, so we kind of, in the beginning, are starting with a fairly simple problem, and we want to think of this as middle school math. If you know the rate and you know the time, to figure out the amount, it's going to be your rate times your time. So 50 cubic feet per hour times 6 hours would give us how many cubic feet we're going to add for this net change. So our 50 times 6, and that gives us a total amount on her driveway of 380 feet cubed. Now, we're going to get some more additional information now, and this is where it's called rate in, rate out problem. At this point, we had a starting amount, and then we had a rate in. Things were accumulating. So now what we're doing is we're looking at our next idea, which is between 6 and 7, she's going to shovel at a rate of 125 cubic feet per hour. Between 7 and 9, she shovels at a rate of 180 cubic feet per hour. So we first want to write a piecewise defined equation for J of t. And this is the rate of change in the volume of snow on the driveway. So if we think about this in terms of derivatives, J of t is going to be the derivative of the volume, that it is the rate of change in our volume. And it's piecewise because we have 3 different scenarios going on. For the first 6 hours, the snow only accumulates at 50 cubic feet per hour. So that's between 0 and 6. At 6, she's going to start shoveling, and she's going to do that until 7. And she's very fast in the beginning. She's gung-ho. She's going to clean her driveway off, and she's shoveling at a rate of 125. However, this is a rate in, rate out problem. That the snow is still accumulating at 50. She's taking it away at 125. So the net rate, the net rate is going to be negative 75 cubic feet per hour. So that's what's going to go here for our negative 75. And also, our last one is going to be the same kind of idea. Still accumulating at 50, but now she's only taking it out at 108 cubic feet per hour, which is going to make the net negative 58 cubic feet per hour. And that's from 7 to 9 hours. Okay, so now we're going to graph our rate function, our derivative function. So I'm just going to remind myself that this is v prime of t. Simple linear function, so it's 50 is our accumulation up until we get to 6, and then it jumps down to negative 75 for the next hour, and then it jumps to our negative 58 until the 9 o'clock. Okay, so we have a nice, simple, linear rate function. So the next question, now that we have that, when is the amount of snow on her driveway decreasing, and how do you know? And this is the same thing we've always done. When the derivative is negative, we know that our quantity function, the volume, is going to be decreasing. So V of t, which is the amount of snow on the driveway, is decreasing, and decreasing, we look for where the rate is negative. Our rate is negative from starting at 6 all the way to 9, is decreasing from, we'll put it in real life terms, 6 a.m. to 9 a.m. And our reason is because J of t, which is equal to V prime of t, is less than 0 because our derivative is negative. Okay. Now, when we take a look at this, and let's kind of go through our process of this accumulation and start making some connections. So I ask, how much is the snow on her driveway at 7 a.m.? Now, 7 a.m. would include all the way up through, here's my 0 to 6, and we're going to 7 a.m. right there. So we want to know how much is on our driveway. Well, you have to remember that it's going to start with the amount that they started with. So your initial amount, and that was at midnight, which was 50. Then for the first 6 hours, okay, we're going to need our net change from 0 to 6. And in that, all we're doing is accumulating at the 50. Oops, sorry, I just realized that should be 80. It's called live TV. The initial amount was 80. Then she has 50, and we're accumulating 50 cubic feet for 6 hours. Okay. Then we're going to have our net change because it's going to be a different rate. So we'll do from 6 to 7. And in that net change, the rate itself is a negative rate because it was negative 75, and we only did that for an hour. And simple arithmetic is going to give us our 305 cubic feet that we have accumulated. But what I want you to notice is that if we look at the derivative function that we have above, if we look at this area underneath of the curve from 0 to 6, and I fill that in, and then I kind of calculate the area of that rectangle. That rectangle is 6 by 50, so the net area inside of this rectangle is going to be the 6 times 50, or the 300. Okay. Then we look at the continuing our process down through here. I'm going to look at this area from 6 to 7. And I'm making this pink because, well, this is below. And so when we look at the net, your net area in this case is actually going to be a negative. Even though area itself is always positive, because our rate is below, we're going to be losing. And so our negative 75 by 1, and that's how we get a net area of negative 75. So that's kind of the amount that we lost as we were doing it. So we started with 80, we gained 300, okay, so here was our gain. So I gained for this section, and then I lost for that section because the rate was negative. All right, so now let's take a look at how much snow was on our driveway at 8:30 a.m. Well, we still have, when we're taking a look at it, the initial amount. So we still have initial amount, which was 80. We still have our net change from 0 to 6, which was 50 times 6. We add that in. We still have our net change from 6 to 7, which is our negative 75 times 1. But now we also have a net change, which was from 7 to 8.5. Okay, till 8:30. And so for that one, we're going to have a rate of negative 58 times time 1.5 hours. And of course, we just do the arithmetic. We add that up. We're going to be at 218 feet cubed. So kind of coming back up to my area discussion, we're going to add, well, we'll say subtract, because this net area here is going to be, oops, and that would be helpful if I stopped. I'll have to fix that at 8.5. So we're stopping right there. So we're looking at this net area, and that net area is going to be the 1.5 hours times the negative 58 that you have there, whatever that's equal to. And that, of course, would be a negative net area, and that's going to tell us how much more we're going to subtract. I think it's 77, negative 77 that we're going to, cubic feet that we're going to subtract for that. All right, so we're going to summarize some important facts that we want to get out of this exploring accumulation of change. All right, the first one is that this very important idea of accumulation. And again, I am interchangeably using accumulation to be the net change in whatever quantity that we are dealing with. And that net change right now, we did the sum of each net change before different times, depending on what the rates are. And so we were basically taking rate 1 times your change in the first time period, plus your rate 2 times the change in the second time period, and so on up until we get to rate n and the change in the nth time period. So we sum up all of those net changes in area, basically thinking of it like if you had a constant rate, it would be rate 1 times the width of the rectangle, kind of what you're looking at, plus rate 2 times the width of the rectangle, and so on. So you can think of this kind of as a height times a width, or the sum of the rectangles. You'll see where we're going with this very shortly. The second fact that we want to talk about is that accumulation is represented by area. So accumulation of a quantity, whatever that is, in this case it was volume, is represented by net area, And what we mean by that, and it's also, let's focus on net area between the rate function, the derivative, and the x-axis. So as we're talking about this idea of net area, area itself is always positive. However, when we do net area, it's what we call as signed area. And so we do have this idea that we're going to add positive or negative to that, right? So when we are looking at the area above, so if our net area is above the x-axis, between your rate function and the x-axis, then that tells us that we have a positive accumulation, which is going to tell me that my quantity function is increasing, okay? And remember, our quantity function is increasing because my rate is greater than 0. Likewise, when your net area is below the x-axis, that means we have negative accumulation, which means our quantity function is decreasing because our rate is less than 0. And I'm going to change color from my last comment on the day. The third most important thing is the current amount of what you have is always equal to your initial amount plus your net change. Okay? All right, and so that's going to finalize our little video for this topic with my dogs barking in the background. Go ahead and complete the check your understanding below before the next video.